Hello everyone and welcome to Data Science Part 3 video with R on Intellipaat. Now before we discuss our today's agenda, do not forget to hit the subscribe button and click the bell icon. So first we are going to discuss about vector. Moving ahead, we are going to discuss about list. Then we are going to learn about matrix. Moving ahead, we are also going to discuss about array. And at the end, we are going to conclude our session with the select function.
So the most basic data structure in R is a vector. It's a homogeneous unidimensional object. So what do I mean by homogeneous? Well, all of its elements must be of same type. Like over here, we have a collection of birds linearly arranged. Now let's go ahead and implement this in R. Alright, so we are back to our studio. I'll start off by creating a character vector and I'll name it as bird. And I'll go ahead and give down some names of birds. So our first bird would be eagle. Then we have parrot, and our final bird would be pigeon. Now let me print this. Right, and let me also go ahead and check the class of this vector. So I'll type class of bird. Right, so we see that this is a character vector. That is, all of these three elements are actually characters. Now I'll be creating an integer vector. And I'll name this as numbers. So I'll just list down the numbers from 1 to 9. Let me print this now. So this is a vector which comprises of numbers from 1 to 9. Let me go ahead and check the class. So I'll type class of numbers. So this is integer. Then we have a numeric vector type. So in numeric, we can give floating point or decimal values. So I'll name this to be decima. And I'll give some floating point values. So I'll just give some random floating point values over here. Let me print this. Now let me check the class. So I'll type class of decima. So see that this is of numeric type, right? And then finally we have a logical vector. And in logical vector, we can just have two values, either true or false. So I'll name this to be logit 100 and give out some logical values. True, false, and if I'm too lazy, I can just give T and F like this over here, right? So let me print this logit 100, right? So these are all of the values of this vector. Now let me check the class. So I'll type class of logit 100. So see that this is of logical type. So this was an implementation of vectors in R. So then we have a list. So a list is a heterogeneous collection of elements. That is, the elements do not have to be of the same type, and each element actually retains its own identity even when it is present in the list. Like over here, we have a heterogeneous collection comprising of a bird, an apple, and a car. So let's head to R and work with list. So this is how we create a list. I type out list, and let's say the first element is the integer 1. Then I'll give a character value, and I'll name it to be Nirvana. After that, I'll give a logical value, and this is true. I'll store this in mix bag. Right. So let me print mix bag over here. So this is how our list looks like. So we have three elements. First is integer, next we have character, and then finally we have a logical value. So let me check the class of this object. So I'll type class of mix bag. So you see that this is a list. Now I'll also go ahead and check the class of individual elements, right? So I'll type class of mix bag, and I'll give two square braces, and I want to check the class of the first element, right? So we see that it is numeric. Second is character, and the third element is logical, right? So let me actually print the list for you guys. So this number 1 is of numeric type, this element Nirvana is of character type, and this element true is of logical type. So we see that all of these three elements retain their original identity or their original classes. So this is how a list functions. Next in line is a matrix. So matrix is a homogeneous collection of elements in two-dimensional space. So over here, all of the elements belong to the same category, namely fruits, and they are arranged in the form of rows and columns. So now let me go ahead and implement matrix in R. Alright, so to create a matrix, what I'll do is I'll actually be using the same vector first. So let me have a glance at this. Right. So now I'll be inserting all of these elements into our matrix. Right. And to create a matrix, I will type matrix. So the first parameter is the data. So for the data, I am giving the numbers vector. After giving the numbers vector, we have two other parameters where we specify the number of rows and the number of columns that we want. So let's say since we have 9 numbers in total, I would want this to be a 3 cross 3 matrix. That is, n row is equal to 3, or number of rows is 3. And similarly, n col is 3, or in other words, number of columns is 3. And I will store this in mat1. So let me print mat1 now. Right. So this is our matrix over here, where all of these are of same type, 1, 2, 3, 4, 5, 6, 7, 8, 9. So these are all integers and I'm storing them in the form of rows and columns. And what you see over here is these elements are arranged column wise. So if I want to arrange these by row, then what I'll do is we have the by row attribute and I'll just set it to be true. Right. And I'll print mat1 now. You see the difference over here. So now the elements are arranged by row 1, 2, 3, 4, 5, 6, 7, 8, 9. Initially they were arranged with respect to column. Now they are arranged with respect to row. Right. So now I'll create a character matrix. So what I'll do is I'll create a character vector first and list down some characters. So let's say I will give the first 6 alphabets. So A, B, C, D, E, and F. Right. So I have created a character vector naming alpha, and this consists of 6 elements. All right. Now I'll take this vector and create a matrix. Matrix. The data is coming from alpha vector. Now, since there are 6 elements in total, I want this to be a 2 cross 3 matrix. Right, so number of rows is 2 and number of columns is 3. And I will store this in, let's say, mat underscore alpha. Let me print this now, mat underscore alpha. All right, so this is a matrix over here. So 2 rows and 3 columns. Now again, if I want to arrange this with respect to row, all I need to do is set by row to be true. Now again, I'll be printing mat alpha. Right. So this was with respect to columns. This is with respect to rows A, B, C, D, E, F. Right. So we have also created the matrix. Now, what if you wanted to access the individual elements of the matrix? So this is how we can do it. So let's say I would want to access this element over here. So all we have to do is set the index values. So this is present in the first row and second column. Right. So I'll give 1, comma, and we have successfully extracted this element over here. Similarly, if you wanted to extract this element F over here, so this is present in second row and third column. Right. So mat alpha 2, comma 3. And we have successfully extracted the element F from this matrix. Right, so this was an implementation of matrix. And finally, we have arrays. So this is just an extension of matrix. That is, it is a homogeneous collection of elements in n-dimensional space. So let's actually go ahead and implement arrays in R. All right, so what I'll do is I'll create a new integer vector and give out values from 1 to 9, and I'll create a second integer vector, and in this I will give the value starting from 10 to 18. So we have created 2 numeric vectors over here, and we'll be using these 2 numeric vectors to create an array. So this is the syntax to create an array. I'll type array and I'll give out the data. Right, so the data is coming from these 2 vectors. I'll use the combine function and give out these 2 vectors over here, num1 and num2. Right. After this, I need to set the dimensions. That is the number of rows, the number of columns, and the number of dimensions. Right. So the dim will be, so in total we have 18 elements. So we have 9 elements in num1 vector and 9 elements in num2 vector. So what I need is actually two matrices of 3 cross 3. So I will give 3 comma 3. So this is the number of rows and number of columns, and since I need two matrices of this type, so I'll type in 2, and I will store this in array 1. Now let me go ahead and print array 1. So this is our resultant array, right? So this is all of the elements from num1 vector which are stored in this part over here, and then we have all of the elements from the num2 vector which are stored in the second dimension over here. Right now, so how can we access individual elements from this? So let's say I would want to access this element number 15. So let's go ahead and access this. I will type array 1. Now let me check where is this present. So this is present in the third row and second column. So I'll type 3 comma 2, and after this, since this is present in the second matrix or the second dimension, I'll give in 2 over here, and let me check the result, and voila. So we have successfully extracted 15 from this. So similarly, if I wanted to extract this element 5, so let's go ahead and do that. So let me actually, yeah, I need this now. So I will type array 1, and this is present in second row and second column. So I'll type 2 comma 2, and since this is present in the first dimension itself, so I'll give out 1 over here, right? And I have also extracted 5. And this is an end to the data structures and also to the end of the session. So thanks for attending, and let's meet in the next class.
If you want to make a career in data science, then Intellipaat has IIT Madras Advanced Data Science and AI Certification Program. This course is of very high quality and cost effective, as it is taught by IIT professors and industry experts.